Okay, 1, 2, 3, 4, 5. Okay. Bum, bum, bum. Hi, everyone. Today we're going to be talking about the last two problems in our little packet full of angle proofs, really. And remember, always, as you should start with the given statements, right? Where you've got AC, okay, is parallel to DF. Okay, that is because it is given. And I like to mark my picture right when I know something is true. So I've got AC. I'm going to put it out here. And DF, that is like right there. And then 2, I know that the measure of angle 1 is equal to the measure of angle 4. That is also given to us. Right, that is given to us. Measure of angle 1, okay, is congruent to angle 4. Right, and I haven't even actually looked at what we need to prove is true yet. I'm just looking through and saying like, oh yeah, I know these things are given to me, but at the end of the day, I need to show that. I'm going to highlight this really quick, that AE is parallel to BF. And remember, if you need to show parallel lines, you're either going to use your transitive property, which you can't do here because you don't have another guy. Like you don't have like this guy over here or some other hidden guy over there, showing that you've got parallel lines. So you can't use your transitive property here, which means you're probably going to use some kind of what would you call it? Some kind of converse that we've got here. So like your alternate interior converse, right? If you've got two lines like, ooh, let's try that again. If you've got two lines like this, right, and these two angles are congruent, then your lines have to be parallel to each other. That is the converse of what we started with. So what I see here, right, we've got these parallel lines to each other. These horizontal lines are parallel to each other, and it's difficult to see, but you do have these Z shapes right here. And this is where it's kind of weird, okay? So you've got the whole angle right here, the whole thing. That is angle 1 and angle 2. And then over here, you've got the whole angle 3 and 4. Those two big angles are congruent to each other, okay? So we're going to use the letters here. Right? We got DEB. That is the whole angle, okay? Let me go back a little bit. You can say that like angle DEB is congruent to angle, and that would be this whole guy up here, CBE. And I'm going to highlight why that's true again. Okay, you do have parallel lines, but with your parallel lines, you have this Z shape. Okay, I always look for those Z shapes. You never know when they're going to come up, but when they do, you want to jump on them right away. Okay, so you've got those two pieces right there. So DEB is congruent to CBE. That is because they are, right? You've got your Z shape, which means it is alternate interior angles. Okay, but you can't just say alternate interior angles. You need to have congruent, or sorry, not congruent. You need to have parallel lines when you do that. Your parallel lines being AC and DF. You were told those two are parallel to each other. So make sure you say, oh, by the way, they're not just alternate interior. It is because AC is parallel to DF as well. Okay, that is a true statement. But here's the thing, right? You've got this big angle right here. This big angle is made up of a smaller angle, angle 1. This big angle over here is made up of another smaller angle, angle 4. Okay. Oh, that got rid of everything. There we go. So what we're going to do is we're going to use that information to show that angle 2 and angle 3 are actually congruent to each other. And then, well, we'll see in a second what that means. Okay? But because you've got angle 2, right, we can say actually from here angle 2 is congruent to angle 3. Your reasoning is a little bit different though. Okay, so your reasoning is because 1, you have angle DEB congruent to angle CBE. Ooh, CBE right here. And also you have, so and you have angle 1 congruent to angle 4. So the reasoning here is that you've got, like, let's say, for example, angle 1 is 50 degrees. Well, that means angle 4, let's try that again. Angle 4 is 50 degrees. Oh boy, I can't read tonight. Well, now if we look at the big angle, right? The big angle is some odd degrees. I don't know, right? If we give it a number like 100, okay? And then we look at the other big angle that we said earlier. This is also 100 degrees, okay? Right? If we just say, I'm just picking numbers right now, okay? If we say, oh, that's true, then that would mean that these other angles in here would also have to be 50, which means these smaller angles in here would have to be congruent to each other as well. So, I mean, if they're congruent to each other as well, there you go. They're congruent to each other. But if you notice, okay, you have that AE is parallel to BF because of your alternate interior converse. Okay, this is a weird one to prove because, again, you have a different Z shape right here. Okay, that is a really difficult Z shape to see. Like, if you're looking at this and you go, oh my gosh, I can't believe I didn't even see that until just now. Don't worry, that is a really difficult one to see. I wouldn't give you something like this on a quiz or a test or something like that, but it's good to look at it now because you will see these Z shapes all over the place, right? You will have just random things like this, and then you're going to go, oh wait, if these are parallel, that means I have congruent angles in here and here. It's weird because it's kind of skewed. Like, you guys right now can like physically pick up your paper and rotate it so that way this is a little bit more upright, so your parallel lines are like left and right to each other. I can't rotate it right this way. All I can do is zoom in and out like that. So I recommend you actually pick up your paper and rotate it and see what you've got. But at the end of the day, here you've got your parallel lines, right? Your parallel lines are congruent to each other. So that is all they asked for. And the reason why, right, if you're wondering, the reason why we skipped so many steps is because I'm not saying like, oh, well, 2 is congruent to 3, and then we're going through and using a substitution property and the transitive property and stuff like that. We could, but I'm skipping that for now. Again, your homework doesn't require something this detailed, so just for the sake of you going through your notes, I just want to make sure that this is making some sense at a more basic level than the detail that would be required normally. So if this is making sense, fantastic. If it's not, come talk to me. I'm perfectly fine with that. That being said, number 15, a little weird, right? You've got these 3 lines. Okay, now I'll be honest, I see 3 lines and I'm immediately going, ooh, can I use transitive property somewhere, right? Because, and I'm making this up right now, I haven't even read the problem yet. So if I've got like A and B are parallel to each other, okay, A and B are parallel, let's just say that's true, right? And then I've got B and C parallel to each other, again, just making it up, I don't know if that's true, then that means that A and C would be parallel to each other because of the transitive property, right? I'm jumping to that because I see 3 lines. I don't know if that's actually going to be helpful, but that's what I see. So let's go find out, right? Part 1, you've got the angle 1 and angle 4 are supplementary. Okay, that is given to us. All right, 1 given. Right, and we should mark that, right? 1 and 4. Make a note, right? Highlight them, underline them, make them stand out a bit. You don't want to put an arc there, right? You do not want to do that because then you're saying they're the same. They're very much not the same. They are supplementary. But you do want to make them stand out a bit. Your next statement would be angle 10 and angle 11 are supplementary. This is also just given to you. I'm going to make this stand out in a different color, right? We've got 10 and 11 are supplementary. And you know what? Just looking at what I've got, I can tell you that this is in fact going to give us parallel lines. And because of those parallel lines, we are going to be able to show that we have different angles be supplementary. So part 3 here, Okay, I'm going to use the fact that I've got these angles right here add up to 180. Now these angles, 4 and 1, are consecutive exterior. Okay, they're consecutive exterior from each other. That means that A would be parallel to B. Right? And the reason I can say I've got parallel lines is because, yes, I've got consecutive exterior angles, but my consecutive exterior angles are also supplementary, right? If you've got like this relationship, consecutive exterior, when you think of consecutive exterior, you should be thinking, oh, are they supplementary? And the answer is yes, if your lines are parallel. However, going backwards, if you know they're supplementary, you can say, oh, yeah, that means because they're supplementary, I've got parallel lines. And that's what we're going to use right now. I can say that A is parallel to B because of my consecutive exterior converse. Okay, that is the converse. That's what gives me my parallel lines. And if you want, mark your picture. Right? Always mark up your picture. It helps you visually see what's going on. But also, additionally, if you're looking at 10 and 11, you can say the same thing about line B and line C. These two angles are consecutive interior to each other, but they also are supplementary. And if they're supplementary, that means your lines should be parallel because they are consecutive exterior to each other. So you've got B is parallel to C. Again, that is because of the consecutive, this time interior converse. Use the converse when you're trying to prove that you've got parallel lines. Hey, look, I used converse right when I said I had parallel lines. I wish that was a coincidence. It's not, right? There is a reason for that. It's because that's what you use the converse for. But from here, once you've got your converse, you can say, oh, by the way, these are also parallel. I'm going to try and mark it like this, right? These are parallel, right? Like this, trying to add 2 arrows because I don't know yet that like A is parallel to C. So I need to mark it differently. However, that being said, I can now say that A is parallel to C because of the transitive property. Okay, because of the transitive property, right? Right, so I've got A is parallel to B, and B is parallel to C. Well, look, A is parallel to B, and then look, B is parallel to C. That means I can go around all this stuff, and I can go straight to C, so that's A is parallel to C. That's the transitive property. Remember the transit, right? Transit, intransitive. This guy right here means like in motion, on a bus, on a train. You are in transit. You are moving, and that is why we call it the transitive property. You're moving from the first guy to the second guy. Oops, I erased my highlight. Oh, no. Come back, please. Thank you. There we go. Okay. We've got A as parallel to C, so now let's take a look. Let's take a look at, let me do this in green, 7 and 5. Ooh, hang on. I thought this was more straightforward than it was up front. It's not, okay? So what we can do here is I'm going to say, this is going to seem convoluted, okay? I'm going to say that angle 7 is congruent to angle 11. Yeah, angle 11, okay? And that is because they are corresponding angles. However, you also know that A is parallel to C. Remember, if you're going to use like corresponding consecutive exterior or something like that, you have to tell me if you've got parallel lines. In between those two angles, yes, you do. Now, you're not using this guy in the middle at all, so cover it up. That's fine. My guy erases when I scribble through it, so ignore that. But just cover it up. Put your finger there, put a pencil there, put a highlighter there. I don't care, right? Cover it up. And then afterward, you can say that you've got those parallel lines, which means you've got these congruent angles. Well, right, if 7 and 11 are the same, okay, the next thing I'm going to say is look at 5 and 11, right? Because I'm trying to relate 5 to 7. That's what this guy's saying. Relate 5 to 7. Well, 5 and 11, look at those two, because I just related 7 and 11. Okay, well, 5 and 11... Okay, angle 5 and angle 11. Ooh, let's try that again. 11 are supplementary. And that is because angle 5 and 11 are a linear pair, Remember, when they're a linear pair, they make a line. They sit next to each other, and they form this line right here. They're making that angle of 180 degrees, okay? Well, since they're a linear pair, and 11 and 7 are the same, that would mean that the measure of angle 7 plus the measure of angle 5 is equal to 180 degrees. This is the same thing as saying they're supplementary. The reason we can do this is because 7 and 11 are the same thing, which means whenever I write 11, I can do the same thing by saying, oh, by the way, this is also true for angle 7. So instead of writing angle 7, I can write angle 11. So right here, this statement 7, says that 5 and 11 are supplementary, but because 11 and 7 are the same thing, I can say that 5 and 7 do the same thing, which they would add up to 180. Okay, and this is because you know that angle 7 and angle 7 is congruent to angle 11, and you have the measure. Geez, what is going on today? And the measure of angle 7 plus the measure of angle 5. Jeez. Everyone erase the last 3 seconds from your brain. Okay? We know 7 and 11 are congruent from each other. We know that 5 and 11 are supplementary. So we replace this 11 with the 7. Okay? So our two justifications are right here. Okay? One of them is that 7 is congruent to 11. The other one is that angle 5 and angle 11 are supplementary. And that's it. That's all you got to do, right? Look at your last statement, see if it matches up with your proof statement, and go from there. If it doesn't, okay, maybe you need to go back and make sure that you're actually proving the thing you need to prove. Otherwise, you have proved it. Go back and make sure it all makes like logical sense. Make sure that if you say that like A is parallel to B, you look at it and go, yes, they are in fact parallel, right? You don't want to say they're parallel and then I'm going to go, what's going to happen is that you're going to say, oh, they're parallel. And then I'm going to say, okay, but are they actually parallel though? How do you know they're parallel for sure? And you have to have an answer for that. And that answer would be, oh, because of your consecutive exterior converse, right? And this is just an example, but you are going to want to actually have an answer for that. You don't want to just say I've got parallel lines because, well, they look parallel. Well, I think they're parallel. Or even worse, well, that would make the problem really easy if they were. I don't care if it makes the problem easy, okay? You need to give me an actual answer. You need to tell me, yes, they are parallel because of a converse. They are parallel because it is the transitive property of parallel lines, okay? You got to give me something more than that. So, I know these last two are pretty tricky, okay? And that's why I made sure that we're doing this video right here. So if you've got questions, you know where to find me. Your quiz is on Friday. I know I'm not here at the moment. You're probably watching this video, or rather, hopefully watching this video. But if you've got questions, you can ask me. Your quiz is on Friday. Let me know if I can help you. Otherwise, good luck. Have fun. If you've got questions, come find me. Bye-bye.